Hello everyone, welcome to the second video in the mock interview series. In our last video, we tried an interview style which some big search engine company would like to use. They typically give you an easy question to warm up, and then they will slowly add the complexity by asking you a bunch of follow-ups. Actually, this will test your CS knowledge and your problem-solving abilities. And this is a great way for them to find the limit of your skills and find the signals in you. So, however, today we are going to try something new. We are going to mimic what will happen when you apply for some big, large social networking company. Typically, you will be given two medium or medium hard questions in these interviews, and then you are expected to come up with optimal solutions and give a bug-free implementation of that solution. So this is also very high standard, since you are not always you can come up with a solution on the spot, and writing down a bug-free implementation can be hard because there will always be some corner cases which you have not think of. So I hope you will enjoy this video. If you have any comments, please let me know. There will be a feedback session in the end, which I will summarize what the interview's strength is and what can be improved. Please have a look at that, and I think that's the most important takeaway from this interview is you can use that tips to improve your own interview skills. So I hope you enjoy that. Thank you very much. Now let's start the interview actually. So we are going to do a coding interview. So I'm expecting you to try attempt two problems actually. So I'm going to emphasize on the correctness actually. So I think we are going to we want to see the type bug-free kind of code actually. So the problem aren't going to be too hard, but we are going to emphasize on the correctness while trying to give you but still please give me the most efficient algorithm you can think of. So the first one would be quite easy actually. So I'm going to just paste in the problem. So you are basically given so if I put in the description here. So we are basically given two sequence pushed and popped with distinct values. So I'm expecting to it return true if and only if this could have been the result of a sequence of push and pop operation from an initial empty stack. So so for example, push. So you can say 1, 2, 3, 4, 5, and then popped is 4, 5, 3, 2, 1. So this can be true, right? So you can think of there will be a sequence of operations like push 1, push 2, push 3, push 4, and then you can pop 4, and then push 5, push pop 5, and then you can pop 3, pop 2, pop 1. So these two are valid sequence actually, but for example, 1, 2, 3, 4, 5, and then 4, 3, 5, 1, 2. That's not a valid sequence combination of sequence because there's no way that 3 can be popped before 5. I think you can try rearrange these operations in any order, but it won't give you the popped array like this actually. So I'm just asking if you can write down a function which taking these taking these two input and then return a boolean to tell me if this is a okay operation or not. Yeah.
Okay. I think the solution is pretty obvious. So I will using a stack, starting with the empty stack, and I will try to see whether I can pop from the queue for each value. For example, I see 4, and my stack top does not have 4, I will just keep use the value in the pushed queue until I reach a state that my top equals to the popped value I want. And after I pop 4, my top is 3, and I want to pop 5, which is not possible, then I will just push the remaining value 5. So if I cannot pop the value that I want to pop, then I will return false. If I finish all the pop value, I will return true.
So about the condition, so like so in which condition you will return false actually?
If I don't see, if I don't see the my top value equal to pop value, I will try to push. Then I will until a state I use up all the push value, I still cannot return the pop value. I will return a false.
Yeah, that makes sense. So can you try to implement this algorithm? Yeah.
Okay, sure. Let me change your. Okay. So I'll each value of n. I will use an index to specify where I'm at for the push the queue. So when I exit this condition, I either has to be this S top equal to N, or I reach the end of the push. So if I say S dot top is not equal to N, then I return. And the other case is my top, then this is return false. And the other case is my top value actually equal to n. Then I just pass the top. And set as empty. Yeah, I think so. Let's go through one example. Oh no, return s equal to empty. Yeah, so if s is empty, then that is true. I use up all the values.
Okay. Can we walk through? Can we walk through an example? Like yeah.
Sure. Let's use let's use the first example.
Sure.
I start with the stack is empty, and I want to for the first time the n equals to 4, which match this condition. S is empty, and also S top does not equal to n, and also IDX right now index is 0, so I will keep pushing. I push 1, 2, 3, 4, and the first time then my S is equal to 1, 2, 3, 4, and now my top is equal to n.
Yes.
My top is equal to n, which this condition does not. Oh, sorry, I think I have to use. Yeah, so S is not empty, and also this is a false. So false and false. So while will be valued as false, you will exit the loop.
Yeah.
And now my S top equal to n. Then this does not gonna return false. I will pop the 4. Now I will pop the 4 and n equal to 5. And now n equal to 5. In this case, I will. The next time I n equal to 5, and I will go see. Oh, this is not empty, but this is S top equal to is not equal to n, so it will be evaluated as true. So I will enter the while loop. I will push the value 5 into the push the value 5 into the stack. So now my stack this time is 1, 2, 3, 5, and right, and then I will pop. And I see 5 equal to 5, which is okay, and then I will pop 5. And then the next time n equal to 3, and in this case I will never enter the while loop because the top always equal to n. So then I will just keep popping my stack until my stack is empty. Then I return true.
But after you've popped 5 here, right? So you have popped 5, you exit the loop, right? So did you see? So
I will not exist. I will not exit the loop. The pop is not used up. The pop is 4, 5, 3, 2, 1.
Oh, okay.
Yeah, first time I use 4, and now I pop 1. I pop 5. The queue still have 3, 2, 1 for the for loop.
Okay. I see what you mean. Yeah. Cool. I think yeah, it's correct. Yeah. Looks correct to me. Yeah. Cool. So I think we can move on to the next question actually. So the next question is a little bit more complex actually. So like I will give you the description here actually. So if I scroll down a little bit and then do this. and then hopefully it will allow me to do this. Yeah, cool. So basically, you are given an array of positive integers, w, which each wi describes the weight of its index actually. So and then, so let me format it a little bit. So let me format it a little bit actually. So basically, we need to call the function pick index with a randomly returned integer from 0 to weight -1, right? Like, and then basically pick index should return the integer proportion to its weight in w in the w array. For example, when for w equals 1, 3, the probability of picking the index 0 is like 1/4, and then the other the probability of picking 3 is like 3/4 actually. And then for each wi, then the sum of the wi should so the probability of picking the index I is wi divided by sum of I actually. So example is so I will give you some examples. So you basically need to return this. So you basically need to implement this pick index function here actually, and then you are given a list of weights actually. And then, for example, if I initialize this as 1, and then my output will be always 0, right? Like, because I have a 100 chance to pick the 0 index. But if I have the input is 1, 3 as we discussed, then you can pick index a lot of times, but it may always return 1, which is the number of 3. But if the number is large, then you can see like it will eventually 0 will come up. So the proportion of 1 to 0, like the probability p1, so p1 versus p0 should be equals to 3 versus 1 actually. And then this is similar situation actually. So basically, you are given a number w. You are given this w array, and then you should be able to return the probability of each with the index of each the index with the weights given at that index. Basically, is the question clear to you?
Yes. I want to ask a few clarification question.
Yeah.
What is the size of vector W?
So the size of the vector would be less than like 10,000. I would think like it's not going to be very huge, but like it can be large. So I would think like it can be from 1 to 10,000 basically.
Okay.
So let's write this down. So basically, you can have your length between 1 to 10,000. I will write this down for you. Yeah.
Yeah, I was thinking I will have a integer randomly generated in C++, there's a rand function which return a value from 0 to the maximum. I think it's from 0 to the maximum of an integer. So I will try to divide.
Let me interrupt you a little bit. So let's do this. Let me suppose you are given a function like a float. Let's call it double. So run, and then so this number will return. I think this will help you actually. So this one number will return you any number from 0 to n less equals 1 with uniform probability. So I suppose you have a function which does this actually. So like you don't need to worry about using a library or like using standard library. And I don't want you to worry about that. I think just assume there's a uniform random function. Let's call it a uniform random function which does give you 0 to 1 uniformly. Yeah.
Okay. In that case, so I will generate a vector. So every time, so you give me a weight vector, then I will generate a vector something like that. So let's use a 3, 1 as an example. So then I will generate a vector in the form of is starting from 0 to 0.25. Well, if the value fall into 0 and 0.25, I will return the first element. If the value is from 25 to 1, I will return the second element. So I will have a vector like that. Maybe I don't need, and maybe I don't need this. I just need this. So if a value is larger than 0 and smaller than 2.025, I will return the first one. And yeah, so is that clear? And the way I'm gonna find, I will use a binary search to find the. So each time I generate a double, I will use the binary search to search where my double should belong to, and then return the indexes back.
I think that makes sense, but I just have one question. So here you give me this array, but this looks like an array of array to me, but does it have to be?
Yeah, it's not necessary.
Okay. Yeah, sure. I think that sounds a good approach to me. So can we try implement the solution you just described?
Yeah, sure. I also 0. Not use confusing. Now use weights. Okay. So for pick index, I will do a binary search. So have 0. So now I'm just going to implement the binary search. So if my boundary that value is smaller than and in this case, which means my meat is too small, I will update my left to become meat +1 because meat itself is smaller. Then there's no reason I still use meat. I can just increment by 1. I'll see down to meat. I think large will be okay. Let's have a let's generate an example helping to visualize it. The probability is something like okay, if I have a value is 0.33 and my starting with 0 and 3 and yeah, my starting position is 0, 1, 1, which is boundary is smaller than random value. Okay, if boundary is smaller than the random value and boundary mean +1 is larger than random value, I think that's good. We can return mean. And if you have a value with my mean is larger, which means too large. My Okay. Yeah, so I think I'm gonna think about an edge case because there's a meet plus one. I want to see whether meet can be equal to the last element, and this will throw an error. Because left is always smaller than right. And if right is equal to the last element, left is always at least one element smaller. So mid will never be able to be the last element. So I think it is fine. So there will not be an error here. So once I finish this, I will just return left.
Yes. Yes, that looks correct to me, but can we try? So for example, here, can we try walk through? Say like if the random number generated is 7, can you walk me through the binary search you are trying to do here?
Okay.
Yeah.
So I start with the left equal to 0. Right equals to 3. Sorry, 0. Right equals to 3, and my mid equals to 1, which is 0.11. And in this case, my first one does not match. You go to my last if state else if statement, which is my boundary plus 1, mid plus 1, which is 0.45. It's still less than 0.7. Then I will update my left to be equal to mid plus 1. Then it's 2. Right is equal to 3, and my mid will become 2. And now my mid is 0.45. And let's go through the if statement again. 0.45. It is smaller than the mid value is smaller than rand value, but my mid plus 1 value is still smaller than rand value. So the first if statement is not useful, and my
So here you are only updating left, right? So and then your left will cross the boundary of mid, and it will become 3. And then it's larger, it's equal to right now, and then you are just returning 3, and then that 0, 1, 2, 3. I believe there's some mistake here, right? Because 0 is never going. So you are not going to have 0 here, right? So in your base array. So this is a bad example, probably. So
I think that's a good example. I need to have an equal statement somewhere in my.
Because I think like in your weights array here, in your boundary array here, you will never have 0 in your initializer, right? Like you are never going to put 0 in the beginning. So you don't have 0, do you?
Yeah, so maybe I need to have yes, I think you are right. I shouldn't have a 0 here.
Yeah. So let's get rid of that, and then let's look at the
last one should be 1 in this case.
Yes.
Yeah. Yeah, let me adjust my if else statement. So my boundary is smaller. It's smaller than lambda w. My boundary mean is equal to right. My boundary is larger. Yeah, I think this one should be okay. Let's use 0.7 example. Should be.
So let me comment on this part out. So you are not going to use this part, if I'm correct. Yeah. So let's see.
Yeah, you can remove it.
Let's comment it out. Okay, cool. So you are going to use this part. So let's try this 0.7 example again.
So 0.3 and my mid is 1, which is 0.45.
Yeah.
And it's less than my my left will be equal to 1 next round. And my mid will be 2. And when the mid is 2 is 0.6. And 0.6 is still less than then left will be equal to 2. Equal to 3. Maybe I need to.
But that's okay because, oh yeah.
Okay. So it should be 2, 3, and mid is 2. And it's still less than, and the left will be 3. And mid is 3, which is 1. And then when it is 1,
you are returning the 3 basically, right? Because you are returning the right here. Because you get out of this loop and then you are returning right.
Yeah.
Let me think. Yeah. Let me do an example on my own. Sorry. I need to be sure about this. So if I say 1, 3, let's use this example, then your array becomes 0.5 and then 1, right? And then if I'm in 0.7, if my number is 0.7, I should return 1 because so anything r less than 0.25, then you should return 0, and then if r less or equal to 0.5, you should return 0, and then anything else you should return 1. So here, like anything less than equals 0.11, you should return 0. Anything less than 0.545, you should return 1. Anything less than 0.6 or equals, you should return 2, and anything larger than that, you should return 1. That's 3. Yes. Yeah, looks correct to me then. I think that's okay. Cool.
You really think so? I adjusted a little bit. I put the equal statement. So I will always make sure the left, if it is correct, the left will not be updated.
Okay.
I will try to make my right to the left.
Yeah. So
and always the right will be wrong, and the right will try to cross the left, and what returns should be the left.
I think this part is still wrong, actually. So this is not. I think this should be mid plus 1, actually. So that's my implementation. Okay. So I think because we are already near the 50 minutes mark, but I think there are we need definitely come back to this, but I will just give you some feedbacks actually. So I want to give a high-level feedback about this interview. First, let me say the interviewee is quite strong. He has the right intuition for both of the problems, and he can reach to the optimal solutions very quickly. For the first one, he has the right idea of using a stack to emulate what's being pushed and popped. I have used this interview question before, and I can say not everyone has this intuition. For the second one, he can quickly identify he needs a cumulative sum array of probability to set the boundaries, and he needs to use these boundaries to pick the index. Also, he chooses to use binary search instead of linear search for searching the correct boundary. These are both big pluses on his side. He can clearly communicate these ideas to the interviewers, which are also very important point. He can take his time to think and will not rush into implementing his ideas, and this is a sign of a very good candidate. However, this is not to say there's nothing to be improved. As the interviewer, I feel the code for both questions can be simplified a bit. For example, for the first one, the condition for the inner while loop is quite complex. It has 2 logic operators, and one of them needs to be parentheses grouped into a parenthesis. This can be definitely improved. I have pasted my solution alongside with the interviewee's solution in the Git link below, and you can take a look and see which one is better. For the second one, the interviewee went back and forth with his binary search implementation. This shows he's not that confident about how to implement binary search correctly, and after a few iterations, the interviewer is also confused and slowly grow out of patience as the time is running out. Maybe to your surprise, binary search is quite difficult to get right. There are a lot of little details you need to be thinking about, which can greatly affect the correctness of your algorithm. For example, when you set the R pointer, do you set it to len array or do you set it to len array -1? What is the terminate condition? Usually people use L is less than R, but that can change actually. So I see people use L less equal than R. What is the correct condition to move your L and R pointers? So usually people use if array mid is less than the value you are looking for, but that can change to less equals or to other conditions. So how should you move L and R? L equals, do you move L to mid, or do you move L to mid -1? Do you move R to mid, and do you move R to mid +1? So this depends on like what kind of behavior you want on your binary search implementation to have. I would suggest you take a look at the bisect module of the Python standard library. It has two functions, bisect left and bisect right, and these two differs only in one aspect, which is where the pointer should go if the value is not found in your array. And if you look at their implementation here, you can see they only differ slightly in their implementation, but the algorithm's behavior change greatly between them actually. So it's a great. I think this is a great source of learning how to implement binary search correctly, and I would suggest to do a few exercise questions to get to see if you can implement them correctly on your in your spare time. So thanks for watching the second video in the mock interview series. Please let me know your thoughts and please comment below your thoughts, and please subscribe. If you want to participate in the mock interview session, I have created a Google form linked below. Please use that form and I will reach out to you. Thanks again. Bye.